A common practice that's happened quite often by maintenance and trying to repair a slide involves coming out and driving a wooden pile or some type of steel pile at the top of the highway slope or shoulder. Usually the situation involves where the shoulders settle maybe a couple of feet or a foot or so. In other words, we've got a landslide that's developed, it's really moved. In order to keep the roadway open, they come in, drive the pile, and then backfill, place a backfill behind it. The problem here is that oftentimes the pile does not extend below the failure plane, or the failure mass is just too large to try to correct. Now, granted that sometimes this may be necessary as a temporary measure, but if you're in maintenance, you should consider this a very, very temporary procedure, and you need to contact a geotechnical engineer or a geotechnical staff of the state to try to come in and study and find out what's wrong here, what's happening in the landslide. This is an example here of where they've driven piles, backfill to keep the shoulder up. This should be considered just a very temporary solution to the problem, and you need to start looking for what the problems are. This slide is a little dark, but what I showed it for was there's some wooden piles. This is a ravine, and they've driven some wooden piles in that particular site. It may or may not work. It should be considered perhaps just a temporary solution to the problem. I suspect there's a lot of drainage into that field. And one thing I might point out is that when you drive piles, you don't control the subsurface waters that we talked about earlier unless you use some other technique to do that. I suspect that the failure in a particular slide like this is probably along bedrock, perhaps, but that's where you need to do a little bit more investigation before you start driving piles. Like I said earlier, the problem is that the bottom of the pile oftentimes is located above what we call the failure plane. And obviously, this is not going to solve the problem. So frequently, pile and caisson type retaining structures fail because the bottom of the pile is above the failure plane. And oftentimes, the wedge of soil that we're trying to retain is much smaller than the large sliding mass. And the pile system is a very flexible system, and oftentimes if it's a large sliding mass, the pile system will simply just rotate out of place or bend as the mass moves. And again, I might iterate, it does not control the subsurface seepage. There's another problem in using the pile system. If you've got real fat clays, and there's some criteria in the manual there, the plasticity index, that's a type of test that the soils engineers use, the greater than 30%, what you get is the soil just simply flows around the pile, and it doesn't solve the problem, even though you may be below the failure plane. So you need to be aware of that particular problem. Some parts of the country, that's a real problem, so piles would not be applicable. In other parts, it may well work in small slides. But when you're using piles, you need to be aware of the pile spacing, the pile bending strength, the pile depth, and the pile anchorage. And that last item there, I'd like to emphasize, is extremely important, getting the pile tip below the failure plane and into rock. So let's look at what we would recommend if we're going to use piles for small slides. Now, I think there's situations where we have used piles for effectively in very small slides. In fact, I did include some of the Kentucky Department of Highways, some of their guidelines for that. They're in the appendix, but let's just be very cautious of what we do. So here's what the recommended approach is, or at least what I recommend. Drill holes, and drill those holes into the rock, and it the hole has to go below that failure plane. Use steel piles, and they should be the steel piles. You drill the hole and then place them in a pre-drill hole. The pile should be anchored into bedrock whenever possible. You need good anchorage for the bottom of the pile. Backfill it with concrete. Or, I think the department has, in small slide repairs, use gravel backfill. And in small slides less than 20 feet, the technique has worked if they observe this type of approach. An example that's has been used in Kentucky, and there has been some success with this. You see in the foreground there, they're drilling holes and they're placing railroad steel in it. This can be obtained at a fairly cheap cost. They're backfilling it with some type of either concrete or gravel there. So some pile guidelines, I'm not going to go into all of these, but generally you have to space the piles about 3 feet or less. And they have to be, as I mentioned earlier, they need to be anchored into competent bedrock or good bedrock. And in the anchorage length, you need about 1/4 to 1/3 of the pile length into rock. It needs to be fixed into the good rock surface. And it should be below the failure plane, the pile tip. In other words, that failure plane, you want it to cut through the pile wall to be effective. If you locate the pile tip above the failure plane, piles are ineffective, as we showed previously in some of the diagrams. It simply just moves with the failing mass. A couple of guidelines there. You need about 1 pile per 100 cubic yards of unstable soil if you anchored into rock. The second item there, you have to be sure that if you can't reach bedrock, you've got to be sure that you get a good portion of the pile length below the failure surface. And again, our little rule of failure mass, the size of it should equal the wedge retained by the wall. It's good policy, that's the top of a railroad pile that's been used to try to correct a landslide. It's good policy to try to anchor that wall of the top of the pile. In other words, use an anchor block, as we saw earlier where the guide anchored the retaining wall. So whenever you can, try to tie the top of it. Another system that could be used of drilling or cabling the system back into bedrock, the top of the wall, and you can gain quite a bit of strength that way by anchoring. Another recommendation before installing pile caissons in large slides and slides greater than 20 feet, you need to consult a geotechnical engineer or the geotechnical staff because in those type of slides you need some type of, usually you need subsurface exploration and you need some kind of design analysis. Now let me mention one other thing. The pile guidelines that were put in the manual were pre-engineered or they have been made up by geotechnical staff of the state's geotechnical staff. So they're only to be applied to small landslides. So you need to observe these guidelines if you're considering using a pile wall. Tied piles or anchored piles can be used very effectively sometimes. Like I say, you should tie the top of the piles, but here's a system where the pile, if you'll notice, it goes below the failure plane. They use cables and they tie the top of it. They either drill or drive another pile section across the other side of the road on the upslope side, and then they tie it, and then they simply come in and put an overlay or a bituminous overlay over the top of them. This is just a suggested approach to correcting small landslides. Another scenario there, doing about the same thing on an embankment that's located on the horizontal ground. Another system, this is an engineered system, tied back walls. When you get into situations where you may have to correct a large slide or where you can use this system for slides greater than 20 feet. In fact, a lot of times you can use this system for correcting fairly large landslides. Up 20 to 50 feet is typical. I think there are cases as high as 85 feet that's been corrected. This is a technique that has been used, I think, in Europe for many, many years, the last 40 years, and it's one that is becoming to be used in this country more and more. Basically, what you have there is a steel tiebacks or strands of wire. There's different ways of doing this. Holes are drilled into the material, and then you have the end of it, steel bars or strands of bars are put in, and they're grouted in place, usually into bedrock. And then you tie off the face of it with some type of anchor plate, and you tie the wall back into the soil or the felling mass. There are firms that will design and construct these type of systems. They've been used here in Kentucky, I think, in recent times quite frequently in repairing some large landslides. This is not a system that perhaps a maintenance person would be too concerned with, but that's a view of the system there of repair of a landslide. But the important thing I wanted to show this is to give you just a brief overview of what the system does and what it looks like. But maintenance ought to kind of keep a record of this, and every once in a while go by and look at the system just to keep an eye on it. And I think this is something that maintenance, if you go out there and you see several members of the lagging and it's crushed or broken or whatever, you should call the geotechnical staff to report this sort of an event so that they may take some action to try to correct it. So that's one reason I wanted to show the system. Let's talk about another system that I think could be used in many, many applications in repairing reinforced slope, small landslides, is reinforced slopes and walls. This is a concept, as you see here, that basically involves using geotextile or plastic grids. And basically it involves placing the plastic grid or a layer of it. These come in rolls, and then placing the soil over top of it, and then putting another layer of reinforcing material in, and coming right on up and building a reinforced embankment. If you look at it for wall systems, basically it would look something like this, as shown in this three-dimensional diagram. You have layers of engineered plastic material, and generally you'd use some kind of granular backfill to build the wall. And what the concept is here, you're reinforcing the backfill material with a very strong, high-strength type of material. This is an engineered product. This is a trade name, reinforced earth wall. They use metal strips to reinforce the backfill. And like I would like to emphasize, that is a trade name. You can use a host of reinforcing materials to build a retaining wall. We mentioned the plastic grid and the geotextile. The metal strips, those are engineered products. But from a small maintenance viewpoint, you can kind of use your imagination. Use something like fencing or guardrails or concrete reinforcing mesh. Applications, well, there's several types of typical landslides that you might use for constructing a reinforced slope or retaining wall. This is a rotational failure. You could simply come in and excavate the soil and use several layers of the geotextile or fabric or whatever, build it up in layers and reconstruct the slope. And one advantage of this is that you can almost build the slope at the same slope it originally was. So that's one distinctive advantage. You could use it to also apply this concept to rotational failures. Here's a particular situation where you've got a failure in the cut slope. You may have right-of-way problems at the top. It's desirable to come in and rebuild that slope about at the same elevation. This also shows that piles were trying to correct the situation, which it didn't. But you could excavate it and use the reinforcing concept. Probably you could use the same type of material that's there, and reconstruct the slope at the same slope it originally was. You use it in wedge failures, both above and below the roadway. Here's a particular application where they're excavating the slope and they're going to use reinforcement. And here's what, in a diagram form here, what it would look like. Basically, you're using either geotextile or some type of plastic grid. These are engineered products, which you can get there's a lot of literature available on. And you come in and excavate the old slope and put a layer of material down, the plastic grid or reinforcing material, puts a layer of soil, and then you alternate coming up. And what you're doing again is reinforcing the slope. The method could be used for repairing little toe slips or toe slumps. It could be easily applied. Slumps in the field, maybe up in the field, just to show a 3D drawing of what it might look like when you finish. You might have something like this. Again, if you're using this type of system, you'd want to put some drainage or subsurface drainage in there. Maybe a layer of gravel at the bottom and run it up on the slope some, and also use a geotextile fabric, filter fabric, to protect the stone if it's a clay material that you're working with. Some advantages of this type of system: you could use on-site materials. In situations where you may have right-of-way problems, you can save space. Also, you reduce the volume of fill you need because you can build these reinforced slopes quite steep. And it provides an economic alternate to other methods. I'd like to say one thing at this point. When we're looking at a particular landslide, there may be several ways of correcting it. This is one alternate, and it's a good alternate. But there is not a way of repairing a landslide. It depends to a great extent on what part of the country you're in, what local materials cost, and so on. So what we try to do in this course is present concepts, and this is one of the concepts. So, and I'm trying to show some of the applications of this particular technique. You can build over weak foundations with this material. This has been used quite often for that purpose. And the good thing about this concept is that once you get a reinforced slope built, you can usually tolerate fairly large movements of the foundation. Just a scenario here or a diagram that shows a particular application. You've got a real steep slope, you've got a failure in the slope, and you simply come in and excavate the material out and build the alternating layers of geotextile or some type of fabric or a plastic grid or reinforced earth metal strips, and you can put the slope back almost to what it was originally. And in real steep mountainous country, this has good application. The steps for reconstructing the slope are in the manual, and I'll leave that to the reader. Basically, it involves rolling the material out, which if you'll notice, there were only 2 men that's required to lift and place that material. Placing the backfill material over a layer, and then compacting the layer. And another thing I'd like to point out that reinforced slopes, what's good about this is that you can run a compactor right up to the edge of the slope. Now, when we build highways, one of the problems, I think, from the design point of view is that it's very difficult to compact the material right at the edge of a slope, say 2 or 3 feet, because you've got equipment that you have to be a little leery of running over. But with a reinforced slope, a real advantage there, you get all the material pretty well compacted. And I think this lack of compaction, especially down in certain parts of the country, where you end up with sort of a loose 2-foot layer on top of the slope, and you get water in that, and you can get these surface slumps or surface slides. So this concept can be used very effectively even in new design, perhaps. So I know down in Texas they have some surface slides situations there on some of their embankments, and they're only 2 to 5 feet deep. And I think one problem there might be that you can't compact next to the slope. That just shows a view of as they come up with the the plastic grids. This is a certain brand that I won't mention here, but it's a very effective way of correcting a landslide and on a steep slope in the mountainous area. Here's a case history in California. You see that's about I think that's about a 45-foot drop from the toe up to the top. They came in and excavated the site, and I think they probably tried to get a pretty good foundation for what they were going to reconstruct. One of the problems there at that particular site was subsurface drainage, so back near the back slope there, the cut slope, they put in some good drainage stone, keep the thing drained, and then they reconstructed it using an engineered plastic type material for reinforcing. And they came up in steps on the thing, and this is sort of a view of the final treatment there. I think this application for maintenance, though, for small slides could be used tremendously in lots of parts of the country where you've got a small slide. So make a note of this technique. I think it's could be applied to many, many different situations. And keep in mind in that particular situation, you couldn't use slope flattening or berms. It's too far down the slope. So you come back and build something like this in steps and reinforce the slope, put it back in, put some good drainage in, and you've got an economical solution there, I think. Other places where it could be applied is, this is a particular wall system that's failing. You could come in and cut this wall out and use a reinforced wall system. Just another site in the mountainous areas where the wall is failing, this could be excavated and a reinforced wall could be replaced there. It's too far down the slope again to put in a slope or a berm. Now you can use there's all kinds of facings you can use for, if you're building a reinforced slope. Here's a timber facing, you can use masonry facing. Here's a geotextile wall, and it's wrapped around the soil layers. You can visualize about 1 foot soil layers. They've wrapped the material there around each layer and reinforced, and they can build very high vertical walls doing it this way. Again, gabion facings can be used in this type of system of reinforcing. Here's a shotcrete or gunite type facing on this slope. You can see that's a fairly large slope or wall system there, fairly large landslide. Another reinforcing material is wire mesh. This is, I think, an engineered product that can be used as a close-up of it to reinforce the slope. Just another view showing the installation of the soil layer there, and they're coming right up with a wall system there. You can use something like guardrail for reinforcing the slope, and metal strips. I think there's a lot of old guardrail around a lot of maintenance places, so this is one concept for building small retaining wall for correcting a small slide. There's a possibility that you could use a system like this. I think California has sort of pioneered this concept, and they've used it out there. Here's an installation at one of those sites. See the metal strips running to the right of the screen there. That reinforces the soil wall. They're using probably a sand backfill for this particular installation. And to your left there is the old guardrail. They've used pre-drilled holes and brought a rod, probably about a 5/8 inch rod or so, right up, and they'll come back in there after they backfill there and put another section of old guardrail in. So you can use some materials like this, and I think probably the cost of this would probably run around, I'm guessing, maybe $15 to $20 a square foot, which would be, for a small slide, wouldn't be too bad. Just a detail of the rod I was talking about. You can see they're threading it. I've got connectors there bringing the guardrail up. There's what it looks like. This is used guardrail. So you can use materials like this, and it's got metal strips sticking back into the backfill. So this is this could be a fairly cheap thing that small maintenance crews could use for repairing small landslides. Another concept is over rubber tires as a possibility, along with metal strips to reinforce slopes, and I think there's thousands of old rubber tires around different places. So this could be used. Just another view of what they're doing here, and they're using the wooden facing and using metal strips, and they're coupling, connecting those with the old tires, and then putting in replacing their backfill. So those are some of the techniques that can be used for repairing small landslides. Now I'd like to turn to mechanical stabilization. Change gears here if we could. Whenever we're making repairs, we need to compact the materials that we place back. Compaction is extremely important. A lot of the details of this is in the manual. We do a lot of things when we compact. Basically, we increase the resistance or the shearing strength of the material to make it stronger when we compact. We increase the density. If we're trying to get weight at the bottom of the field, we increase the weight of it so we get more resistance there. So those are two really important things when we compact. Techniques that are used, mechanical compaction is first, or just compaction of soils. And then there's a lot of specialized or highly specialized techniques that probably maintenance wouldn't be involved, but for completeness sakes we include them in the manual, or at least a note about them. But we're mainly concerned in repairing landslides of compacting the materials. Just two general concepts you need to be aware of when you are dealing with materials in repairing landslides is that there's two types of basic soils: cohesive soils, which are basically your clay type materials, and what we call, or geotechnical engineer would call a cohesionless soils. And these generally are clean sands and gravels. But we need to be aware that if we're compacting clays or what we call fine-grained soils, that there's certain types of equipment that's used to do the compaction. If you're compacting coarse-grained soils, there's certain types of material, certain types of equipment that are used to compact the material. And some of the criteria is outlined in the manual. Just if you're compacting clays, you would want to use something like this. This is called a sheep's foot roller, and it's got feet like sheep, and that's where the name came from. And it's used for compacting heavy clays and clay-type soils. Vibratory rollers is one type of compactor for gravel or coarse-grained materials where it doesn't have much fine material in it. Also, if you're building rock berms, compacting them in 2-foot lifts, you can use just the tractor itself. You can push the material in about 2-foot lifts because crawler tractors vibrate and can compact the material. These methods are specialized. You wouldn't be involved in these type of things in maintenance. Another technique that could be used to repair landslides is chemical stabilization. And what we're doing here is adding some type of chemical to the soil, and we're going to change the properties of the soil. There's several methods that can be used for that purpose. Generally, when we add the chemical to it, we make it stronger, and mainly that's one of the things we're after. Hydrated and quicklime have been used. These techniques are used in a lot of states now in the U.S., but it's techniques that have been used quite often in Europe. We can use cement, fly ash, and then combinations of these type of materials. We can use bituminous materials for stabilization. There's a considerable number of applications, but for repairing small landslides, sometimes when it's real wet at the toe of the slide, we could use some type of chemical such as lime or cement for constructing the working platform at the toe of the slope. We could use it in constructing flattened slopes and berms. just for constructing a foundation for retaining walls. We could use it for that purpose. Basically, for repairing, say, a small toe slump, I've just showing the repair technique. You'd excavate the material, mix it with something. If it's a clay, you can mix it with, say, hydrated lime, and then put it back in place, compact it and put it back in place. So that's one possible application. You have to be aware, though, there are certain situations that you use, say, something like lime. Certain types of soils you have to be aware of where you would use cement or bituminous or asphalt. So criteria, say, for lime stabilization, the plasticity index has to be greater than 12%, and it's best applied to soils that classify A4 through A7. Now, I realize the maintenance engineer may not understand some of the criteria, but at least the criteria is there. He can go talk to a geotechnical engineer and maybe look at the local type soils that's in the landslide and decide if he can use that technique. And then also he may want to do a little study of it to see if it would be economical. Say if he's next to a plant that makes hydrated lime, may be real cheap to consider. Henry?
Tom, one point here on using the chemicals is very important to remember, I think, is that lime, unlike cement, is when you're using that for a stabilization purpose, whether it be slopes or subgrades or whatever, you need to be careful because more is not better in the case of lime. You have a certain percent whereby that you get by determining your pH factor of the soil. But if you use a certain percent over this, then the actually strength could go down. So more is not better in the case of lime. And cement, this is probably the case that you will reach a maximum cement. The more you use, probably a little bit better that you'll gain the strength. But I think that's an important thing. So you may be adding too much, be wasting some of your money, and maybe not be getting as good a product. So you'll want to be awful careful when you use when you use the chemicals.
That's a good point, Henry, and one well taken there. But anyway, there's some criteria. I've outlined some of it. You can read that. Also, there's types of tests that we can perform to determine, say, if we're considering lime stabilization, what percent of lime we need. And as Henry mentioned there, more is not necessarily better, but there's sort of an optimum percentage which has to be determined in the laboratory that you could use. There's some simple, I might mention that the last, let's see, the last method listed there is a very simple method. Wait a minute. Well, I'm sorry, let me back up here and just go through some, just give you a brief view of what construction steps are involved, and then we'll talk about percentage here in a minute. Well, you'd have to determine the percent of lime, which they're listed 4 tests, 4 different ways. You would first come in and scarify and pulverize the soil and spread the lime, spray the water, and then you'd mix it. To get a real quick way, as I was saying there, to get a quick handle on what percent you might need, you could use this simple concept. This is just a replot of some data that came from Texas, some test data that was used there. If the liquid limit of the soil is less than about 50%, just multiply it times 0.12. They give you a ballpark figure to use for a small landslide repair. If it's greater, use about 5.5 to 6%. On that slide, you can't see the left of the graph there. If you look on the manual, you can see that graph. But that's just a quick way of getting a percentage. And this was based, this data was based on a lot of test data. So that shows just a scarifying operation, a type of plow that might be used to, or disc to pulverize and mix the soil, one technique. Of course, this shows a big truck, lime truck spreading hydrated lime onto the subgrade, or I mean onto the soil. I might mention for small landslide repairs, you probably wouldn't be involved in use this type of equipment, but I'm just showing some slides here to show you what's involved in the technique. Actually, hydrated lime comes in bags. For a small repair, you just simply lay the bags out onto the soil that you removed, and you could use just a plow or something to mix it up, and then let it sit there and cure maybe 48 hours or so. These are shots. Actually, this technique was used in subgrade stabilization, but the point here I'm trying to make is that you could use this technique for mixing bad soils. In other words, if you've got a real bad clay, real weak and wet and so on, this lime can dry it up and increase the shear strength properties of it, make it stronger, and you actually can end up with a fairly good material after you get through mixing it. But here again, you need to observe the criteria. This shot just shows spraying water on the hydrated lime, and then they'll come back and mix it. Here they're using a mixer on the back of the grater here to mix the stuff up. These are commercial type operations. One reason I'm showing this is because it's the only slides I could get my hands on. But this is a fairly big operation. But the concept is here that you could use bags of lime, and the National Lime Association has criteria for how to space the lime for so much material that you want to mix. So there's a lot of criteria available there. There's just another way you can mix it using some type of scarifier to mix the lime and the water up. And then you would cure it and finally mix, maybe sometimes you might come back and mix it again, but for small repairs you probably wouldn't have to do it. But when you're putting it back in place, if the slide is large enough, you can get a sheep's foot roller in, you would compact it in, and then you would have the thing repaired. There's a lot of other products that are mentioned in the book, fly ash, there's some criteria there. I won't go into that in depth, but you can read about that. There's combinations of lime fly ash, and there's some criteria of when you could use that. Criteria for cement. There's certain situations where you can use cement, but let me caution you that using it real high plastic or fat clays, you will have problems mixing it. But some claim that you can use it with all soils. But generally it's best used, at least on my personal experience, with sandy materials, and it makes a good product. It can really strengthen the material up. One concept you might do is use thin layers of cement to stabilize soil if you've got a sandy material available, and make a reinforced slope that way. Bituminous stabilization could possibly be used for sandy materials, and there's criteria outlined in the manual on that. And then there's a lot of combination stabilizers, and I won't go into all of these. Let's turn our attention now to rock slopes. Rock slopes, of course, is one of the big maintenance problems that we face, I guess, in the whole country. There are certain things that we can do to try to lessen those problems. Basically, I would divide rock slope mitigation measures, things we can do, into three areas: slope stabilization, protection methods, and warning methods. And what I want to do is just very briefly look at each of those. One thing I'd like to mention here at this point, that in your manual, these typical diagrams we showed earlier in the program, we've included some advice or guidelines for the maintenance engineer or maintenance supervisor, just showing some of the things that he could do, and basically some of the things that he needs to be aware of. So that's in the, I think, Appendix A of the notebook. Rock slopes, of course, as we've seen today in several of the slides, is a major type of problem. Here was a differential weathering type thing where the smaller material weathered. I mean, the dark material there is probably a clay shell or a shell material, a very weak material, and it's weathered, and the toe support's gone for the massive sandstone layer on top. This is a real headache to maintenance. When they go out there and look at something like this, they're going to have to go out there and clean it up. That's one of the functions of maintenance, I guess, but sometimes it may involve a lot more than just what they can handle. They may have to let real large rock falls to contract. But our slope stabilization methods, we talked about excavation. Sometimes the only solution, which is a very expensive solution, is merely go back and cut the slope back. We try to avoid this, of course, because it usually is very expensive. We talked earlier about drainage methods, and one of the things that maintenance should be aware of on rock slopes is trying to keep the water away from the slope. Another technique that's been used in some parts of the country is shotcrete, and also there's support and reinforcing systems, which may be a buttress or a concrete column supporting rock that's about to fall, but these are all very expensive solutions. But we might just look at this particular type of problem here. Obviously, when you get large chunks of rock falling into the road, it's something that maintenance will have to clean up generally, and it causes a real headache. But shotcrete is a pneumatically sprayed-on concrete surface, as shown in this slide here. Just a little bit of detail there. This is a slope protection method. Generally, it's applied for fairly hard shales or where you've got that underweathering or weathering type situation. And essentially involves drilling in or placing cemented grouted dowels, and you use a wire mesh which is placed on the face of the slope. And generally on that dowel there you have two plates, one in front of the mesh and one on the back, kind of a spacer type thing, so it comes away from the face slightly. And then they simply take gunite or shotcrete, which is a sprayed-on type concrete, and they call it shotcrete because it's sprayed or pneumatically. This has been used on some repair methods, but it's not very effective when you use it against this type of situation where you've got a soil slope. It'll just weather out from under it. But it has been effective in some situations like this where you've got a shale layer there that's been weathered, and they use that to try to stop or slow down the weathering process. So it's a fairly expensive solution sometimes, but in some cases it may be desirable or may be necessary to use something like that where you've got a real problem. That's just a close-up of the shotcrete after it's hardened. And it's been in, I think this has been in for quite a few years, hadn't it, Earl, in Tennessee? So it seems to be holding up fairly well. Another system that's fairly expensive are anchor boats, as shown here is a close-up of it. A better view of what they're trying to achieve here, they're simply drilling in or placing bolts into the rock to try to hold the slabs together. If you'll notice that in this particular rock formation, you've got a lot of joints there, so chunks of that slide off and fall into the roadway. So what they've attempted here is to reinforce that slope with anchor boats. One technique that's kind of interesting in one type of cut slope failure, they simply came in and built a berm, but the way they did it was kind of interesting. What they did, they drilled and blasted the rock and then heaped it up in place for protecting or stabilizing the landslide. So something like that sometimes should be considered, I think, because it would be expensive, but it's something to consider. You don't have to haul the material in. Basically what you're doing is using the material in place. Protection methods, there's a host of methods, and this is generally, in rock cut slopes, this is what we're doing, or some of the cheaper methods. It doesn't necessarily solve the problem completely, but it does aid in protecting the roadway. You can use materials that may be readily available, such as dirt, a rock, where you can build a rock or a dirt berm, basically, in place, and catch the material before it enters the roadway. Another technique that's been used is called a slope drape, and essentially that consists of placing a wire mesh over the slope, and what the principle here is, you're trying to dribble the rock down the slope. In other words, control the movement of the falling chunks of rock. Just another view of a slope drape at the top there. you notice that the drape is anchored into bedrock or some kind of anchoring system. Here's another view of the drape. They're using cables to anchor it, and they sort of hang it out over the slope to some extent so that when the rock falls, it sort of controls the fall of the rock. So it just lets it slowly fall down through behind the mesh and then into a catch zone or a drop zone. In other words, that keeps it from bouncing down onto the roadway. Another view of the cable that's supporting the system. Now, might mention that this is not something necessarily that maintenance would probably be involved in, but they could if we develop some pre-engineered plans for given types of situation. This is where the inventory, if you knew what some of the problems you're having in a particular locality, you could draw up some standard drawings for particular situations, which maintenance then might be able to go in and install on a particular slope. So that's the anchoring system or the post that's holding the drape up there. You can see that it's anchored quite deeply into the ground. Another view of it. Catch fences. I think Dave mentioned this earlier in one of the sessions. Use chain link fence. Generally you may have a lot of this in maintenance around. Simply build a fence and try to catch the rock before he enters the roadway. This is a double wall chain link fence. They've used spacers there, and they've also used a safety barrier as another protection. But one thing about fencing like this, it absorbs the shock of falling rock fairly well, whereas if you're using a concrete safety barrier, it'll simply bounce or even break the concrete. So you may end up with a double problem. You may have the rock in the road, but you may also have a chunk of the safety barrier in the road. Another view of a catch net or wire meshing, trying to control the fall of the rock. That slide doesn't show very well, but that's more a catch net or a wire mesh put over the face of the slope to try to control the falling small chunks of rock. As I mentioned, concrete safety barriers can be used to protect the roadway from falling rock. As I mentioned earlier, let me mention one thing here. This is a slip form wall that's poured in place. You notice they've got a wide zone there between the wall and the slope, and it's wide enough where they can get in there and keep it cleaned out from time to time. So this is maybe a maintenance operation type thing. This particular little graph here, I put it in the manual for one reason then, that it's some criteria that's been developed, I think, in 1963 by a fellow named Ritchie. And it's used quite a bit, I think. If you know the height of slope and the slope of the slope, you might say, you can design or you can figure out what the width of the drop zone might be, or the zone you need for catching the falling rock. And also there's a graph or a table in there that gives you, if you know those two factors, slope and height, it tells you what width and depth you should have. Now, this is used for new design, but in checking those slopes, it could be used to check those slopes to see what width and depth you need for a catch zone there. So that's one reason I included it. Back to safety barrier walls, you can see that sometimes they're not very effective totally. Of course, when you get into real large falling rock, it can knock the wall out or knock chunks of wall onto the highway. But still, it is a method of protecting the slope. Here's another view of, you can see the size of that rock there. It's beginning to stretch the capacity of this type of wall system with that size of rock. So probably up to 2 feet or so is about what you could expect to catch with a safety barrier wall. Another view of the failure there, the rock slope failure, breaking the wall. Now here's an interesting concept when you have to do scaling of a cut slope. where you're working above, but you've got to protect the roadway, and this is one that was used down in Tennessee, and I thought it was ingenious of the contractor. He used old cars from the dump or car lot, the discarded cars, and he stacked them up, and he put a metal band around them, tied them together, and hauled them to the site. And it really is a pretty effective system, I think, because it's this type of system is a good cushion or a shock absorber, so he protected the roadway. And I saw this personally several years ago when I was driving to Tennessee, and I really thought that was neat. Gabion walls, I think, are a good system to use for protecting or catching rock, falling rock here. They're fairly easily to install, as we talked about earlier. They're good shock absorbers. Rocks can hit them and they'll not bounce back or bounce around too much, but they sort of deaden the fall of a rock. Just an example of use of a gabion. It's in the left of your screen there. But also they've included what I call a drop zone for the rock. And also it's wide enough where maintenance can get in and haul or clean up the rock and haul it away. And if you're in a situation like this where you're hauling rock away from a waste area like this, here's where the inventory system would be very valuable, because you could stockpile that close to where you're having distressed embankments or near failures, or simply on a real large field place the rock at the toe. So it's a good way to waste the rock, but you could pre-plan these type of operations, I think. Warning methods.
Tom, before we get into that, just one comment, something you didn't mention, which we probably should mention.
Sure.
That is, benching is not in here as a remedial treatment.
Well, I thought I mentioned it earlier. I didn't go into any details on benching or maintenance. Pardon?
For rock slopes?
We mentioned it earlier in one of the sessions, I think. I didn't get into any great detail, but we have used benching in Kentucky quite a bit for that purpose. But that's for maintenance purposes. That I mentioned it was a very expensive solution, and it's not something that maintenance would be involved in doing themselves. I think I mentioned that they might be involved in cleaning the debris or rock off the bench. So,
that's important.
Yes, that is an important role of maintenance, is probably to keep those benches clean.
Right.
And here again, that material could be hauled to put at the toe of other embankments. So that's another good reason for using the inventory.
When I was looking at that Ritchie criteria that's on page 196,
yes.
What happens is if they don't clean the benches, what happens is you build up an angle that projects the rocks way out on the highway.
Start
That's
bouncing out,
really important to understand.
Mm-hmm. Yes, good point. I want to wrap this rock slopes up right now. There's other methods, warning methods. The last three there probably are not very important for highways. I think some of the railroad people have used some of these techniques, but the first one there may be the only solution you have, a rock patrol. In some areas of California they use it. In the mountainous areas of the west they also use it. I know personally down in Tennessee they have a certain section there. In fact, a lot of these photographs came from I-40, that particular section. And they just have simply either a one or two man crew with some type of heavy-duty truck with some type of frame or plow on the front, and they simply drive the highway from time to time, cleaning debris out of the road. And that may be the only solution you can get to, because otherwise it may cost a great deal of money to go in and try to change slopes. So some situations, that's the only solution, is use a rock patrol. Now, I'll wrap this up pretty fast here. So far, we've talked about basic approaches to repairing small slides as well as large slides. But we've talked about modifying the slope, controlling drainage, and constructing stabilizing structures. Fourth technique is removal and replacement. Basically, what we're doing here is maybe cutting the top part of the slide off, replacing it with lightweight material, such as engineered products, lightweight aggregate, or a material of lightweight concrete called elasticell. But we could use something like sawdust if it's readily available in a particular area. And another thing that's not listed there is cinders, which is we obtain when we burn coal. These are lightweight and have very high strength. So the basic concept, again, is to take material that, from the field, the top of the field or the slope or failure, that weighs perhaps 100 to 130 pounds per cubic foot, replace it with one maybe weighs around 50 pounds per cubic foot. What we're doing there is decreasing the driving forces on the slide, and we're, in a sense, lightening the load on top of the slide. Sawdust piles, there's certain areas of the country, sawdust is available. If you're close to a source like that, it's a good application. One particular example, you can see in this roadway, there's fill settlement, probably a couple of feet. They come in and excavate the top of the field and then haul in the sawdust. Here's another shot of it, and replace the top of the field. One thing, though, one problem you'd have with sawdust is it may rot, but one thing you can do is to spray it or try to encapsulate it with asphalt. So in some slides, instead of driving piles sometimes, or depending on the situation, if you've got large settlement, or instead of, what I meant to say, instead of putting in 10 feet of asphalt, come in and put 10 feet of sawdust in. And I think that could be very effective. It may not last a long, long time, but I think some of these sites where it's been used will last quite a long time. So it's one technique that to consider because it's lightweight. And incidentally, I can tell you that sophisticated tests that have been done on the strength of sawdust give very high shear strengths, and surprisingly so. So it's, and of course you probably, when you're putting it in, I'd compact it maybe a foot in foot lifts and compact it quite heavily. So you can compress down as much as you can, but it can be very effective. Finally, on our basic approaches, the only solution that may be available sometimes, and I've been in a situation where relocation is the only solution. Simply try to avoid the problem. Like I say, it may be the only feasible and economical solution. Either build around or over the slide, and I've been in a situation where we recommended closing the road and building or using an alternate route. And in a lot of county situations, this may be done, but of course you can get into some politics when you make a recommendation like that. So one particular site where relocation was used is a fairly simple technique. You'll notice to the left of the screen, along the center line there, you've got cracks, and they simply went over and excavated the slope, the cut slope there, cut it back, and moved the road over. So that is maybe the only solution in some cases. So basically, I'm going to wrap this up now, but one other thing. We've talked about basic approaches to repairing slides. We've talked about repair methods. Let's talk about, real quickly, the economics of repair methods. I guess if you're a maintenance supervisor or whatever, and your boss calls, you have a landslide that's curved out there, he's going to call you back in and say, what's it going to cost to repair that slide? What's the bottom line? Well, if you consider slope flattening or berms, these are data that we took from our records in Kentucky, and what we did there was plot the cost in dollars per foot or linear foot of landslide versus the height of the field. It's not a terrific relationship, but it is quite revealing, I think. You've got a very good trend there in the data for a good relationship there. If you know the height of the field, you can come up vertically and intercept that trend line and go horizontally across and get the cost per dollar of running foot. In other words, let's look at a little diagram here to explain this. When you're doing your inventory on a landslide, here's the way it would work. You would take your tape measure, the cloth tape, measure the width of the slide, and then doing a quick cross-section with a hand level, you could get the measure from the toe to the top, the height of the slide. Now that graph was in 1 foot width, as I show in this diagram. So an example. Say you have a height of slide that's equal to 20 feet. The width is 200 feet. Say that you can correct it using a flattened slope or berm. A quick cost estimate then, go into the graph, get the cost per foot of slide, which in this case was $175 a foot, times 200 feet, the width of the slide, cost you roughly $35,000 to repair that particular slide. Now that's just a quick estimate to maybe satisfy the boss or someone. It gives you a ballpark figure to start figuring from. Another technique that you could use, in this little graph, and it's a little bit clearer in the manual, we've plotted here, again, the volume of fill, and that should be yards per cubic yards of feet, against the height of a flattened slope. Now what I did there was just assume that your original slope was 2 horizontal to 1 vertical, and say that you're going to use, say, a 3 horizontal to 1 vertical flattened slope or so on. Well, anyway, you can use that graph to get the estimated cost, get the volume of fill that you need, and you may have to make an assumption that yardage or cubic yards of material at a particular location. A lot of new construction is around $3 or so a cubic yard, but I doubled the cost there and made it $7. If you're involved in a particular location, contractor, or it's going to cost you a little bit more for that type of operation. So anyway, you can multiply it times 200 feet and you can come up with a quick estimate that way. Keep in mind that particular figure doesn't involve removing guardrail and some of the other things you'd have to do, whereas the previous figure does. Say that you want to use some other system. The data I show here, you can see it probably a little bit plainer in the manual, but this comes from a study in California where they compared different wall systems. Here again, I've converted the data for inflation, or I've adjusted it for inflation using a construction index from the Department of Highways here in Kentucky. I think this data was published in 1981, and I've adjusted it using that construction index. Here again, you know the height of the wall. If you know the height of the wall that you need to calculate or solve your problem, the landslide, you can merely come up vertically and get the cost per linear foot, and then multiply times the width of the slide. And these examples are given in the manual. You can see that the cost would vary quite a bit, but still it would put you in the ballpark. You can see also that wall systems can be very expensive. But the point I want to make here is that I'm not advocating one system over another, just that different methods or local materials may vary and so on. So it does give you some quick way of making a quick estimate of what a landslide will cost to repair. If all else fails, you can do what one local person did in the mountainous country of Kentucky. I guess he didn't get a response from one of the county officials. He took matters into his own hand and used some old cars. You note that's not a bad technique. He's flattened the slope there. He's got vegetation. He's reseeded it. Actually, nature reseeded it for him, but he also is controlling the erosion that's in the bend of a river. So it solved his problem for this little county road, which is located at the top of that. That's the slope of the failure there. Finally, I think that wraps up the session 5.
Could I have the first slide, please? This section we're going to start is entitled Legal Liabilities, and I want to say to you this is the 6th session, and it's the last one, and I have only 10 slides, so you might be glad to hear that. It's been a long day, I'm sure. I think most of us know that safety is an important factor in all of our highway improvements. In fact, in my estimation, it may be the most important factor, whether it be in design or whether it be in construction or whether it be in maintenance. I think sometimes we forget that maybe this is the most important factor in our daily work as we try to provide that service for those traveling people on our highways. I think we should also understand that every effort should be made to try to eliminate and reduce the landslide hazards if possible. I think the thing that surprised me most when I was trying to do some research for this last session was to find out that in one state a study had indicated that 80% of the landslides was due to human activities. In another state, 90% of the slide, they said, had been due to human activities. I kind of cringed when I read that because I was hoping that attorneys didn't read that statement, because just reading the statement without background information would lead you to believe that most of the slides was due to human error. That is not what is meant by human activities. We want to talk a little bit about the legal aspects of slope movements. As you well know, I'm not a lawyer, and I did research as many documents as I could find. However, you can't find any guidelines that's been given to the courts on how to decide court cases involving landslides. In fact, it's very difficult to track what has happened with any kind of lawsuits dealing with landslides, primarily for two reasons. Number one, a lot of the slides involve large corporate agencies, and they settle out of court. Number two, it involves public agencies, and as you know, some public agencies still retain the sovereign rights that you can't sue them. Many states, although most states now are losing that sovereign right protection, and we also know that cities and counties are having difficult times even getting liability insurance because of the number of liability lawsuits they have annually. Since most of the litigation involving landslide relates to the construction and maintenance of public roads, and that's usually done by public agencies, you can assume that the public agency is always going to be the defendant in the case, and I think that's been true in many of the cases that I was involved with when I was with the Transportation Department. I think you have to understand that there's been numerous cases in which private property has been damaged or a person has had personal injury resulting from landslides on public highways in our country. In these instances, the liability of the public agency having jurisdiction over the highway has varied from state to state. I want to say that it's true that there are many different kinds of interpretation of court cases involving landslides, so it was not possible to find any cases to put in the manual for you to look at that could be generally said is true in most states. With regards to landslides, I think it should be understood that there's two categories that cause lawsuits. Let's look at this one called legal rights. The first category, I want to read this because this is legal technology and language, and I want to be sure it is underscored in your manual. It's on page 208. The first category, a property owner's rights and response to the invasion of the property by sliding material or interference with the lateral support of the property by construction or maintenance of a public way, is the first category. Second category involves a highway traveler's rights in tort against a public agency for injury sustained from a landslide that has resulted in part from the negligent construction or maintenance of a public way. Let's talk a little bit about the landslide encroachment onto another adjacent property. A person has a right to sue us not because of existing state statutes, but primarily because of the Fifth Amendment to our Constitution in the United States. It says in part, I think all of you have been well aware of that if you take a person's property, you have to pay him just compensation. You extend that concept, says that if you damage his property, you shall also provide him just compensation for that damage as well as the taking of that property. So when we're talking about the liability for a landslide, we're not talking about existing state statutes. We're talking about the Fifth Amendment, which says that he is due just compensation for that. In studying several cases, it may be concluded that if the public works activities result in the creation of a landslide or the reactivation of an old landslide that causes damage to private property, the public agency is liable for the full extent of that damage. And I can attest that that's a true situation, because when I had the opportunity to serve as Secretary of Transportation, it almost seemed like that lawsuits came at least weekly, and either on construction jobs or maintenance jobs. And you know, in Kentucky we have a saying that if you have $1 and you know the location of the courthouse, you can sue. And in many cases they do sue. Now the second category is talking about injuries sustained from a landslide. Although the courts have made it clear that a public agency is, this is an interesting statement, by the way, and I want you to underscore it in your manuals on page 210. Although the courts have made it clear that a public agency is not an insurer of the safety of persons using its highways, in certain circumstances, travelers are protected by law from landslides. In other words, they're saying we don't have to guarantee and ensure safety, but in the case of landslides, in some circumstances, they've been able to sue and win. Some states have statutes that impose liability for the dangerous condition of public property. But I think if you look to try to find some general statutes, common thread running through all the state statutes, it's not possible to find that. This dangerous condition must be the result of negligence, a wrongful act, or a failure of an employee or public agency to act within the scope of his or her employment. Thus, liability depends upon whether circumstances and conditions were such that the danger was reasonably foreseeable in the exercise of ordinary care, and if so, whether reasonable measures were taken by the public agency to prevent injury. An interesting term that's now becoming as popular in the lawsuits as reasonable is foreseeable. A public agency, since it is not an insurer of the safety of the travelers on its highways, need only to maintain highways in a reasonably safe condition for ordinary travel, under ordinary conditions, or under such conditions as should be reasonably expected. If you just look at those words in there, such as ordinary travel, under ordinary conditions, as should be reasonably expected, you understand what lawyers use to make their living. These words are highly debatable, and this is the reason they are anxious to take you to court. The same thing applies to the word foreseeability. That's been held as a necessary element of contributory negligence. It must be shown that a reasonable person would have foreseen the exact consequences of negligence. The next statement happens to be true for Kentucky, and it only happened 2 years ago, in 1986. The doctrine of contributory negligence has been replaced by comparative negligence in many states. And Kentucky did this in 1986. Under comparative negligence doctrines, negligence is measured in terms of percentage. Any damages allocated are diminished in proportion to the amount of negligence assigned to the plaintiff. In other words, this is a complete change in the way that our court cases handle comparative negligence or lawsuits. And I would suspect that also in 1986, if I'm not mistaken, we had a cap on our lawsuits at $125,000. It's now been raised to $250,000 that the state can be sued. So you can see what's happening with the liability. The final subject I want to talk about is risk management, or I like to talk about it in terms of management of risk. In other words, in your position at the local or city or state level, what should you be doing to be sure that you are doing the best that you can to avoid, well, you could be sued, but going into court and have the best chance of sustaining your position. So what I've done here, and in your manual, I have listed 9 things that I believe if you had this kind of proof when you went to court, if you were sued, I believe you got a good chance that the jury if it is a jury trial, would say that you had conducted yourself in a reasonable manner as a public employee. Number one, establish a regular record for inventorying and inspecting highways under your agency's responsibility. And you've heard that. If you don't remember anything else from the course today, the first step in managing your slide problem is to tell how big a slide problem do you have on the system that you're responsible for maintaining, be it city, county, or state. Number one, find out what you are really responsible for. The only way you can do that, and the only way you can manage your slide problem, is to figure out how big, how many slides is your slide problem. Number two, record all the inspections and notice of change in any of the slide areas. Number three, after noting the movement on a potential slide area, make regular inspections using inspection forms and diaries. Diaries are a must. Number four, document your actions relative to corrective measures taken after you've made the inspection. Number five, after identifying this slide movement, take photographs. You heard Tom relate to that earlier. That's a must. That says more to a jury than anything else. And take those photographs at each inspection. Number six, erect warning signs at sites which you cannot immediately make repairs. Number seven, take routine corrective maintenance actions as soon as possible to improve safety at the site. And number eight, if your routine maintenance, and I wish you'd just write in there in your manual, and even extraordinary maintenance, routine maintenance and extraordinary maintenance does not provide a safe travel way for the public, program a design project immediately for reconstruction and/or rehabilitation. When I say program, that means put in the planning stage or put in design stage, so if you have to go to court, you said, look, it was a major improvement. It was not in my budget, but I took immediate action and had a design project program. And number nine, the last, the most important aspect that, if you don't remember anything else, keep good maintenance records. I think that's true of almost anything we do or we're trying to manage, is that we must keep good maintenance records. But also call to your attention one other thing I found in reading, that there's a book out called Killer Roads from Crash to Verdict. If you haven't read this book, it'll probably scare you to death, but I still think you ought to get it for your library. It's really a lawyer's book for another lawyer. It's how to sue. And most engineers that's read it are terrified after reading it. But I think you ought to read it. So if you haven't read it, I think you ought to try to get your hands on the book, even if it is terrifying, because I think it'll really shake you up a little bit in terms of how you ought to manage your risk as it involves your responsibility in maintaining the highways. I think we should always recognize that the goal of all of us that's involved in transportation of people should be the safe and efficient movement of people and goods within the physical constraints, and that's PHY, and it's also FISCAL, both physical and money-wise, and you always have some of those constraints. Go back to what we started out early this morning. What's the purpose of this workshop? Purpose was to provide guidelines for city, county, and state maintenance supervisors for making decisions relating to the maintenance of slopes and slide restorations. I think Tom and Dave have covered the subject very well. There are parts of the things that we did not cover that's in your manual, but I think all in all there are some excellent guidelines for decision making. One other thing I'd like to say to you is that in the table of contents I noticed, I'm just going to read very quickly what each of the appendix, and we're going to put that in the final manual. Appendix A is geared for the maintenance supervisor, and it's for slide and rockfall features. Appendix B is an inventory form for slides and also for inventory form for culverts. Appendix C is slope design and analysis. Appendix D is the Transportation Cabinet's guidelines for using railroad rails for retaining structures, and Appendix E is a decision chart for mud flows. We need to put those in the content so that we have made reference to them during the course of the workshop, but I think that needs to be written into the content so you can easily find those when you need those. Gerald, that's the end of today's video.